Hello, this is Matt Oswald. Welcome to Keeping It Classless Labs. This is going to be an introduction to static routing. I'm not going to go all the way back to the beginning of what I would consider to be some of the fundamentals of Cisco networking, especially some of the CCENT concepts that you would learn, such as basic subnetting and things of that nature. By this point, you should already be somewhat familiar with that concept, as well as working with the Cisco command line. Other than that, we'll be going into some of these concepts in pretty good detail, so that you know what you need to do to configure this stuff. So static routing, and I guess routing in general, static routing is used to manually specify where packets should be sent. If you think of a network and you have many interconnected routers, or maybe in particular the scenario that I'm showing you here, you've got two routers separating a total of three different networks. You've got network A and network C, which is what people usually think of first, because those are usually where the hosts are connected on those subnets. But there's also a network in the middle, which is the network that's used to connect the two routers. And whenever you have a router, you know that you are connecting multiple, two or more networks together. That's what routers do. Routers are designed to get packets from one network to another. That is their core function. It's actually the definition of routing. So we have these devices that do this for us, but we have to live by a few rules. Namely, routers only know about the networks that they are directly connected to by default. For instance, the router here, let's call it R1, is directly connected to network A and network B. And it will know about those because it's directly connected to them, and obviously, as a result, will know about them. But it has no idea that network C is out here, because it is not directly connected to it. It's that network is actually directly connected to this router over here, which we'll call router 2. And actually the problem occurs in reverse. Network C and network B are directly connected to this router, and as a result, this router has no idea that this network over here even exists. So routing, static routing, or actually dynamic routing with routing protocols, which we can talk about later, is used to tell these routers about some other networks that they may otherwise not know about. And static routing is by far the most manual process. I was going to say easiest, but in some ways it's actually more difficult, especially if you get into larger networks. But it is a manual process. It's a quick way to make a small change without having to set up an extensive routing protocol. It's a useful technique to use when simplicity is called for. So the topology we're going to be using today is shown here. We're going to have a simple network here. We're going to have two routers, very similar to the diagram I showed you before. And each router will have their own LAN segment, represented by the switch and PC you see there. This is going to be done in GNS3, and I will make the copy of the lab available offline, where you can practice on your own and do those kind of things. So that's the topology we're going to work with. So for today's lab, we're going to need to do a few things, and I mentioned that we're going to need to delve a little bit into subnetting, but this is just to get us practice with that concept and make sure that we've developed our network appropriately so that we can actually do our static routing. The first requirement is we need to address all the networks using the 172.16.0.0/16 address block as efficiently as possible. This means we need to break apart that address block and use subnets as efficiently as possible. And the requirement below that, or I guess the specification, the requirement for the hosts, the number of hosts on each LAN segment, is 18. So it says subnets with hosts on them should provide at least 18 usable IP addresses. So if we go back, we know that we need to provide 18 addresses at least for this network and this network, because there are hosts directly connected to it. This network, we're not bound by that requirement because there's no hosts on it. And I'll explain in a little more detail later what exactly we use to address this network. So we're going to be focusing on these two networks for that 18 address requirement. Second requirement is to set up static routing so that all networks can reach all other networks. So back to reference the previous slide, we've got these PCs connected to these networks, and by virtue of the router's default configuration, router 1 doesn't know about this network over here, and router 2 doesn't know about this network over here. Pings going from PC1 to PC2 or vice versa won't work because those networks are disjoined by this network in here. And so we need to do static routing to allow those routers to pass packets correctly. And then finally, we need to create one default static route that will route all remaining traffic to router 2. So I've loaded up GNS3, and the topology is very similar to what I just showed you. In fact, it is exactly the same because I took a screenshot of it. So we have our two routers, and the first thing I want to show you is these PCs. In GNS3, you have the ability to configure. I don't know how you pronounce it. I think it's QEMU or QEMU. I'm not sure, to be honest. But those are micro Linux hosts. So you can go into here and configure them and do all that. I cheated a little bit. I actually already configured these per the addressing requirements that we will explore here in a little bit. So I won't go into detail on how they're configured now, but they are small Linux boxes just for our ping tests, that kind of thing, just to ensure connectivity. So that said, let's do the first requirement. We have to address all of the networks using that address block, and we need to do it as efficiently as possible. So the basic rule of this kind of concept whenever you're called upon to do this is you need to subnet and allocate addresses for the largest known LAN segment first. So if we look at our diagram here, we know that we need 18 addresses because the requirements say that we need to provide at least 18 usable IP addresses. So we know that we need to address those networks first because that's our largest requirement, and that's because we don't have any requirements for this network. So we know that these are our largest, and we know that we need to give those addresses first. So just for reference, let's put 172.16.0.0/16 up top. Let's put that there. Alrighty. So let's work on this network first. We need 18 hosts. Well, we know that there is a subnet mask that allows us to do 16 hosts, and that's not going to cut it because that's too small. So we're going to have to go one up, and let's say I think the next one's 32 hosts, or 32 IP addresses rather, only 30 usable hosts. So we have 32, and the subnet mask for that would be 256 minus x equals 32, which is actually 224. So our subnet mask becomes 255.255.255.224. And that is our subnet mask for this. That'll give us 32 IP addresses and then 30 usable IP addresses here. And that's much more than our 18 requirement, but that's actually the smallest one that does actually supply the right number of IP addresses. So that's cool, and actually, matter of preference, I don't like displaying large subnet masks on my diagrams, as well as most other people don't. I usually break it into CIDR notation, which is 27 for this subnet mask. So remember, we're using 224, and the CIDR notation is 27. So that's our subnet mask, and actually, we're going to go ahead and copy and paste this over here, because we already know that we have the same number of hosts required for that network. So we'll work with that later once we figure out this address space. So we have the address space up here that we can use, and we haven't used anything yet, so we can start at 0. So we can go from 172.16.0.0, and that's the network number, and then the subnet mask. Our usable IPs are going to be .1 through .30. Because the network goes from 0 to 31, and the next network begins at 32. So we've just figured out the addressing for that network. So we have usable IPs from .1 to .30. Next, we have this network over here, and we can begin right where we left off because we need to address this network next. And we know that we left off at 31 because that's the broadcast address for that first subnet. So the next usable IP, or I guess the next IP address, which would be the network number, is 172.16.0.32. That would be the network here. And then as a result, the usable IPs are the next one, which is .33, and it goes all the way up to .62. And those are the IP addresses for that. So we've addressed the LAN segments, the ones with the hosts connected to them, but we haven't addressed this WAN segment, which could represent maybe a WAN connection between two remote offices, for instance. Um, it's actually a pretty unique IP requirement here. There's only two hosts, so we actually only need two usable IP addresses. And if I were you, I would commit this to memory because it's not only called upon, all the time, but I think it's kind of cool. It's my favorite subnet mask, and it's a /30, which is actually, let's do this right, 255.255.255.252. If you look at the math, 255 minus 252, or I'm sorry, 256 minus 252 is 4. And if you subtract 2 from 4, you get 2. And the reason you subtract 2 is for the network number and the broadcast address. So you actually end up with two usable IP addresses. This is the subnet mask used for point-to-point links because you only need two addresses. You don't want any more than that, or else you'll waste addresses, and that'll allow you to do that. So, like I said before, the CIDR notation is /30, and to call upon our previously used range, we go from 33 to 62, and then actually up to 63 for the broadcast address. And the subnet number for this for the next subnet up here, which is what we're going to be using, is .64 because that's the next address that we can use. 172.16.0.64. That makes our usable IPs for this subnet .65 and .66. Okay. It looks like we have addressed everything to our heart's content. Let's get to configuring. So I have PuTTY windows open for router 1 and router 2. We're going to look at router 1 first. It looks like we have a serial interface and a fast Ethernet interface. We're going to go into global config mode on router 1. I'm going to drag this over here, running out of space. And we're going to configure the LAN interface first so we can get that working. Interface fast Ethernet 00. And we're going to give it an IP address of 172.16.0.1. That's just the first usable IP. Typically, you'll see that on a router configured. If you have like a default gateway, for instance, for hosts, it's the first usable IP in a subnet. You don't have to do it that way. It's just a common convention, if you will. So we have our address, and the subnet mask that we used, if you remember, is 255.255.255.224. That will allow us to have 30 usable IPs. Enter, and we'll issue a no shut to bring that interface up. Okay. Exit, and let's go to interface serial 00 while we're here. We need to address the WAN segment so that we can get connectivity working between the routers. So we're there, and we want to use the address 172.16.0.65. So let's give it that. 16.0.65, and then the subnet mask is 255.255.255.252. And no shut there. I think I already ran that when I was configuring them earlier, but just to be safe. And that should be it. We're going to exit out and save our configs. And we're done with router 1 for just a second. Let's finish addressing our network on router 2.